The 1995 Nobel Prize winner for the genes of embryos, embryonic development. Can I start with you, Louise? You've given us a lovely introductory talk in the lunchtime session, which some of the people here will have seen. Can you just briefly, in less than 2 minutes on these introductory questions, please, gents and ladies, can you set the GMO debate in the context of plant and animal breeding and the Green Revolution?
Well, for most of our history, of course, we have not been breeding very systematically, and systematic breeding actually started in the 19th century. We did select, of course, for desired characteristics, and it's taken an enormous impetus after 1945. We then started to breed for very specific characteristics. And if you look at the developments in genomes now, I think the big thing is that because we have sequenced the genome of a number of important crops, such as rice, such as now cassava recently, we actually know what we're doing. However, it is very clear that knowing what we're doing is important for the toolbox of biotechnology. It does not necessarily lead to GM crops. On the GM side specifically, most of the GM work has gone into, certainly in the beginning of the years, into something called herbicide resistance. That was part of a system whereby you planted crops and made sure they survived in a situation with lots of weeds. That herbicide resistance has created a lot of resistance in society because you were doing all the wrong things, large-scale, mechanized agriculture. But in recent years, particularly the example of BT, which is a resistance built in from a bacteria against various types of insects, has meant a tremendous positive effect for the environment and for human health. Small farmers, because this is not linked to big farmers, small farmers growing cotton cotton in countries like India or China actually use far fewer or no pesticides at all. There are no deaths related to the overuse of pesticides, and it's been an enormous benefit. Can we extend that benefit to other crops? That's really, I think, the challenge. And in that sense, the most important thing to remember is that we must keep that knowledge in the public domain. It has to be accessible, especially to poor countries and poor farmers.
Torbjörn, why has there been such resistance in Europe in particular to genetic modification?
I wish I knew. I really don't understand it. The empirical support in favor of GM crops not being any problem is very strong. We are growing at present something like 150 million hectares of GM crops worldwide. The accumulated acreage having been grown since the first introduction of GM crops is something like 1 billion hectares. It's about half of the total acreage of the whole world. And there is not a single instance of any serious problem having been caused by these GM crops. The Commission in Brussels has devoted, I think, 300 million euros, which is a huge amount of money, on tailor-marked risk research on GM crops. Again, no negative results have been found, and yet we have this very strong resistance in Europe and not in the States, not in Canada, not in South Africa, to the same extent at least. My only understanding of how we ended up in this very bizarre situation where a very promising field of science is being demonized to the extent that it's vanishing from Europe. My only explanation is that agriculture in Europe is in general not an export industry, which it is in, for example, Australia or in the United States. If we increase productivity in our agricultural business, this is generally perceived as a problem because it creates a surplus which we have to sell on the world market to the underpriced prices. At least that's one explanation. I wish I knew.
Dominic, set this in the global context for us. I mean, how are we going to bridge the gap between the growing demand for food and the availability of supply, do you think?
Well, I thought the poll you did was interesting. It seems that it was more optimistic, it seemed, than I thought it would be. But if we look at just the numbers, we see up to 2050, as I think Stephen Chu showed us, the population growth and what's happening, we're going to need to produce about 70% more food than we have today, which is an inordinate amount. I think there was even a UN panel that said the next 50 years will be the equivalent of what we've done cumulatively over the last 10,000 years. And obviously there were smaller populations back then, but that's just the size of it. And that demand is going to happen no matter what, not only because of numbers of people, but we're going to have 1 billion new middle-class consumers in Asia, primarily in China and India, over the next 10 years that want to eat a move from grains to higher protein food. So that's what we have, and yet at the same time we've got diminishing, available land. There is more land that we can find to be able to do it, but we're sort of hitting the margins of that, and we're seeing that in almost every commodity. I would just say that as we look at it at McKinsey, we've had the last 100 years we've seen a downward sloping commodity price curve, and I'm putting a whole bunch of things in there, but that includes food. And as we look forward over the next 50 years, we think it's going up. It's going to be shifting up as we move it. So I think that the need for applying genetics to food is going to be a critical component. I don't think it's the only component. I think there's a lot of things that can be done with the small farmers in Africa and India in terms of scaling them up. I think there's a lot that can be done with waste. We waste a lot of food upstream in developing countries and a lot of food downstream in developed countries. I think there's a lot there, but there's no question, at least in our minds, that we are really going to need to apply the science to be able to cross that gap. Now, again, a couple of vignettes. If we look at Saudi Arabia right now, just on current consumption, we'll run out of water in the next 10 years, just given what they already have to do. So we're going to, I think, face some pretty severe challenges. And I think one of the things we need to be looking at is what are the regulations that we can put in place. I worry about the anti-GMO feeling, just to put my cards on the table on that side. But I also think in terms of the R&D that's being done, are we spending enough? The pharma industry is spending about 10 times more than the ag food industry. The ag food industry is fairly concentrated. There's some extremely good organizations in there, but as Louise said too, it's in a fairly narrow set of crops. We need to broaden that. So again, I think the need is huge. I don't think we've seen it in our history as humans, but I hope that the science can help close a big chunk of that gap.
Thank you. Tikki, one of the aims of genetic modification is not just to give people more food, but to make them healthier. How do you see genetics generally contributing through agriculture, through nutrients and so on, to human health in the future?
Okay, I want to sort of address two issues. The first one is what you just said. What are the priorities in plant and animal breeding in the context of current global health problems? And I see this as revolving around infectious and chronic diseases, most importantly, antibiotic resistance. In fact, if you speak to public health people, many consider this to be the public health challenge. And the third one would be malnutrition, which is linked to the issue of food security. And I'm a little bit on the pessimistic side because of the potential impacts of extreme weather and climate change. So I would say the three priorities in my mind would be, the first would be food crops with disease, herbicide, weather resistance, and perhaps higher nutritional value. Because for under 5 mortality, for example, almost 40% of these children actually have an underlying malnutrition problem. The second priority would be the possibility of plants and animals actually being used as factories for producing drugs and vaccines. I think Stephen indicated bacteria as producing artemisinin. Could we increase the yield of artemisinin from the original plant where it was derived from? There was Charlie Arnzen many years ago who talked about edible vaccines. So where is that idea now? I think it's turned into using plants to produce vaccines rather than actually eating a raw potato, which I guess doesn't sound too palatable anyway. And the third priority on my list here is a more rational use of antibiotics in the livestock industry. So those would be my three. I just want to also address, in the context of the challenges that we need in terms of further applications. Louise, you asked me to address this. And I like to paraphrase the late Senator Paul Wellstone here from the United States. And he basically said that to get progressive change, be it whatever context, you basically need 3 critical ingredients: public policy, grassroots organization, and electoral politics. Public policy gives you direction and an agenda for action. Grassroots organizations builds a constituency to fight for change from the bottom up. And electoral politics is the main way we contest for power and hold decision makers accountable. So I believe those 3 ingredients that Wellstone identified is something we need to keep in mind in the future.
Thank you very much. Christiane, I think there's an interesting question here. Why hasn't it been possible for the organic movement to embrace genetically modified foods? Because in a sense it is a very organic technology in the sense that it involves biological change rather than chemical applications.
I think it has already, many things have been said before, but I think there is a big resistance, especially in Germany perhaps, against science somehow. I mean, people tend to believe Greenpeace more than scientists. And there is a certain skepticism towards modern biology, especially genetics. And one notices it at all fronts. And also the politicians tend to sort of embrace organizations such as the BUND or Greenpeace or NABU or whatever, and instead of listening to scientific manifestos coming from, for example, academias or the Deutsche Forschungsgemeinschaft or so. And it's strange, and it has a history, and maybe it's stronger in Germany than in other European countries. But I also would like to point out that Europe has probably a more benign climate and less pests than other countries. So we are not so much in need of it. So if it would really bring a terrific economic benefit to us in Europe, then probably we would adopt it. But this is not the question here. It doesn't matter whether we use GMO or not, because we have lots of subsidies, and it just is all controlled. And so the people do not really pay for what they
get paid whether your crop fails or succeeds.
And this is something which I really fail to understand. Also, you ask for the organic farmers, why don't they use it? GMOs, because they could save a lot of disease. I mean, especially, in traditional farming, you use a lot of pesticides to get your crop to develop, to grow, and this is something which can be avoided if you use, for example, BT resistant. Crops which are made BT resistant with BT, and this is, of course, very successful in countries where the pests are really very, very important. So also more southern European countries now adopt it, in Spain or so. But in Germany, it's not of much relevance, I think.
Mm-hmm. Do you want to
Can
come
I
in?
react? Because I think there is some... the truth of this discussion has to be to go into the details. One of the main problems is that we generalize too much about GM crops. And there's a very good example of extreme relevance to Germany and Northern Europe of potential GM applications, and that is in potato.
Yes,
potato is vegetatively...
discuss potatoes, yes.
Potato is vegetatively propagated. It is very sensitive to high humidity, and it has some major fungus diseases or other types of diseases. Think of the Irish potato famine, which was a major problem. We are now able to do two things that are really interesting and that may change the debate. One is that we have identified the genes that actually give some protection to various fungus diseases or various other insects. But the other one is that we can get those genes actually from very closely related progenitors. So we're not talking about what we call in genetics wide crosses, where you get a gene from a bacteria into a plant. But we're actually talking about the wild relatives of potato that are still alive in the Andes and take some of the resistance from there. That process is called cisgenesis, so it's very close to the original. And that means that you're not crossing the species boundaries in the same way. And you only use the genetic toolbox to introduce that gene from something that's really very related. And I think what we should do as scientists is explain exactly these details and show that there is a possibility to do something which indeed ends up with a transgenic variety, but is so close to the original that it shouldn't feed the fears that people have of thinking of a strawberry that has a gene from a fish from the Arctic and then becomes something completely different. So the issue of risk, in other ways, really has to be communicated in a much more detailed fashion.
Christiane, do you want to come back on that?
There is this potato which has been developed by the BASF in Germany. Yes. Yeah. And they look very, very interesting with two resistant
also public
genes.
Research. It's not just commercial research.
Excuse me?
It's not just private sector. There's a lot of public sector work in there.
Yeah, but I mean, the company in Germany did not have been successful in conveying this message to the public, although it was propagated in the press quite a bit.
Was that transgenic or cisgenic? Was that
exactly?
It was transgenic. It was cisgenic.
This is a potato which is resistant to this fungus, which caused the Irish
and nematodes. Disease. There are various properties addressed at the same time.
And they have given up. They have just transferred all their.
It's interesting this. Because a lot of the arguments made against GM crops have now been, as it were, answered. Either you say, well, this isn't transgenic, it's cisgenic, it's from within, or you say it's not for profit, like golden rice, it's going to be given away for free, nobody's patenting it, There's no Terminator technology to say that it can't breed with itself, and still people object.
Yeah.
It's almost like you sort of answer each objection, but it doesn't seem to make much difference. I don't know if that's...
Deeply rooted distrust.
Say again? Deeply
It's
rooted.
deeply rooted distrust, and in Germany in particular, it's also this, the benefit by the companies. The people really resist that, and this is so strange. I mean, of course you don't give cars for free, but people sort of expect that the seeds can be for free. And then many people don't understand this is something really, you can try to explain it. For example, for corn, you cannot take the corn from your crop and seed it again and get the same harvest. You have to buy the seed because it's hybrid. It's a hybrid. Yeah. People don't understand. They fail to understand it.
But that has been around for a long time.
Because people don't know the Mendelian laws, and they cannot follow the rationale. And in India, in the case of the BT cotton, they now have made crops, they have made seeds which you can propagate yourself. And this is, of course, really very good, because the farmers do not have to buy the seeds anymore, and then they can use it themselves. And then this resistance to, yes, these companies all make a lot of benefit by selling them very expensive seeds, and this kind of thing can be ruled out. But in Germany...
Torbjörn, you wanted to...
Yeah, I just want to stress and agree with you the importance of judging GM crops case by case, just as any other crop or variety. And this is what I mean by this concept of demonizing, that the technology in itself has come to be demonized to an absurd extent. It's like saying that you're against electricity. I mean, any technology can be used for something good and something bad, and you have to choose the good applications. And the same is true for any technique of plant breeding, not only gene technology, but conventional techniques as well. You can create bad crops, and you can create good crops. You can... There can be big multinational companies creating these crops, or there can be small companies. And you can be against multinationals, or you can accept them. But the GM technology in itself cannot be neither bad nor good. It's the application that is either bad or good, and we have to choose the good ones. And there are lots of good ones which we throw out now because of this demonizing of the technology itself. And that's a tragedy.
Tikki, you wanted to...
Yeah, I just really want to directly build on what you said just now about you have to take it on a case-by-case basis. And to cite a recent example from health, there was a release of genetically modified mosquitoes to try to disrupt breeding of Aedes aegypti, which is the main vector for dengue fever. Now, these transgenic mosquitoes were released in Florida, in Key West, in Brazil, and in Malaysia. Yes, there was some opposition, but what I found interesting was that the release of these mosquitoes were very much welcome in Brazil, less so in Florida. And so I believe the case-by-case is important, because my own view is there could be some important cultural and value differences between Florida and Brazil. In other words, in many developing countries, the community is more important than the individual.
There's a big difference between that case and GM foods in some way, which is that the consumer might benefit. And, the ordinary person might not get dengue fever. And so he can immediately see the benefit, whereas he can't see the point of a GM tomato. He can see the advantage to the producer, but not to himself as the consumer. I think is that one of the differences that's coming through? That once you can give people an immediate benefit from a technology, they're more interested in it.
But the Irish famine, when 30% of the Irish population starved to death in the mid-1800s due to the potato disease late blight, that was perceived by the individual. Now, that is precisely what BASF has presented a solution to, and that is precisely why they had to pull out to North Carolina, because they couldn't stand the European opposition.
But historical evidence is usually not very strong for today's consumers. I really think that if the introduction of GM crops had started with a tomato or a wheat that had a gene from cabbage that protect against stomach cancer, we would have had today a very completely different debate. However, the question now is to find those applications that actually do confer benefits, a more specific benefit. And one of the reasons why this food debate is so difficult is that everybody, all of you, prepare at least 3 meals a day. Everybody feels he is an expert on food. And food in cultures has an extremely strong connotation of ritual, but also of morale, of ethics. There is good food and bad food. That has nothing to do with the objective biochemical properties, but because of beliefs and religion and so on. So the question now is really also one of changing the ethics, of discussing again how our food chain is actually organized. And I believe the resistance against GM is part of a larger resistance which runs along the lines of being against multinationals, being against intensification, large-scale production, dependency of food chains that actually go from one continent to the next, the resistance against the way animals are treated, the whole debate on meat. All that is in fact caused by one enormously important factor, and that is that we are in Europe a highly urbanized society where only a few % of the population actually works in the food sector, and where most of us really don't know where food comes from and what all the steps and decisions are that are embedded in every meal you eat. And I believe it's this lack of understanding that creates a kind of nostalgia for grandmother's past, which suddenly now looks from the vantage point of middle-class societies as a mythical time when food production was still good and close to us. And I think that is a really important moral and philosophical issue.
Dominic?
Yeah, just building on this, I mean, I think too, back to this historical view, the world's changing very, very quickly, and I don't think we realize the urgency of it. I mean, as we look at sectors around the world, we actually think, Louise and I were talking about this before, ag food is going to be one of the top 2 largest industries in the world. And if you actually look at the way the value chain is set up, it's a prehistoric value chain. You compare it to other industries, it's very fragmented. The R&D research that goes on, the wastage that occurs, it is a broken, not fit for purpose industry. And we've got to change it quickly, because this is 2050 is out there, but 2020 is now. That's 1 billion people coming in, and that I also I think we also have to look at the other side of things, which we don't. That shortage of food and water creates conflict, war, and water doesn't tend to worry about political boundaries and where it flows and so forth and how it works. And you just see this if you're in China today, and I think COFCO, the food company, imports the equivalent of 40% of the agricultural output of China a year. That's what they're importing. They have to feed that urbanizing population quickly. And so you start obviously seeing people now in Ethiopia where there's lots of actual land available, people trying to buy land, secure supply. So the thing, I worry that the urgency level and understanding level, including amongst ourselves, I'm not saying we know it, is not where it needs to be. And so this education about how food actually works, what one eats, to me it goes with healthcare. And the last thing I'd just say, I found very interesting, there's now some food companies that are very much going into healthcare, and healthcare companies that are going into food for the various reasons that you see it. I think you can't separate the two. And I think we should be doing everything we can to be encouraging more science and R&D in that area, because it's way below the levels that it needs to be now. And I think that's something that all of us should be promoting, educating, and policy making on.
You say that the ag food system is broken or is inadequate, but as Secretary Chu said this morning, it is an extraordinary success story that we have fed 7 billion people without taking an extra acre under the plough for cereals, at least. And a lot of that is mechanization and fertilizer, but some of it is also genetics. Old-fashioned genetics, if you like, but Norman Borlaug has been mentioned several times, and that is an extraordinary piece of work. And more recently, of course, we have been messing up the genomes of our crop species on purpose, using X-rays and chemical mutagens, but blindly, without knowing what result we're going to have, and nobody objects to that. That's called, what's it called, mutagenesis or something, and it's the normal way of producing new varieties. And
we don't know that.
We don't.
People don't know
They
this.
don't have no clue that all the food we eat is totally unnatural. They have no clue. They think this is natural.
Golden Promise barley, which is used for beer making, for organic beer making, was produced by using X-rays on barley seeds. It's an interesting one. Anyway, sorry, I'm supposed to be chairing this.
You were saying, though, is that we're doing a lot, and we are doing a lot, and that's great that I'm not Malthus, or I'm not. I can't remember who was on the picture saying that it's the world's going to end. I'm just saying, though, that's for 7 billion, with many of people who are malnourished, by the way. We're going to 9 billion with 3 billion middle class that are going to demand meat. And it's going to happen. So it's a big delta, is what I think, and it's happening very, very quickly. Yeah. And what I'd say about the fragmentation is you just look at it, everything from the inputs, from the, if you will, the farm to fork. It's very fragmented. And by the way, a lot of the emerging countries are doing some of the more advanced agriculture. Brazil, we've mentioned. If you go and look at one of the large-scale farms in Brazil, it's amazing. They're the ones that are actually buying drones from the U.S. because the farms are so large you can't drive out there.
But the European public is even more worried about. Your example that is very environmentally friendly intensification, which I agree to, is not at all something that the European public wants to know, because the European image of good farming is small farms, the farmer with his animals, the wife still making the cheese, this kind of nostalgic 3 generations back agriculture. And the interesting sort of disconnect is that we accept modernization in lots of technologies, but we don't accept it in food. And my premise here is that we should really start at primary school to actually teach young people about where our food comes from. And you can do lots of wonderful things. Look at your your sandwich with peanut butter. There's a whole story to be told about the peanut butter, the wheat, and it's a fantastic, fascinating story. And we haven't been able to integrate our knowledge of the food chain and the history and the fascination for that in our education. And so by the time people become adults, they have these very primitive, in a way, images of what the food chain should look like. And I think that to do that and to get GM its proper, modest but important place in there would be a tremendous asset. And I would really ask all of the audience to think about educational opportunities to get this debate going. And a debate which may even be open-ended. We may not necessarily need to say, okay, it has to be only one way, which is another thing that European audiences don't want. We want to have choices and options. And the question is, what are the best options for the future?
In about 10 minutes, I am going to come to the audience and ask for you to join this conversation. So get your questions ready, but we'll just have a couple more then. Torbjörn.
One route forward that is being discussed in Europe now, and in particular, at least in Sweden, I know, is if we should make environmental impact assessments of various food chains, be they built on GM crops or non-GM crops, and start by scientific means to analyze which kind of growing systems, which kinds of systems for producing food for us have the least environmental impact, negative environmental impact, which have more negative impact. And I think that's one possible avenue forward, because that would
organic bean sprouts organic bean sprouts in Germany didn't have a great record last year.
No, exactly.
That outbreak which killed 50 people.
But there is strong opposition to such an idea because of the ideological connotations.
Exactly, because I think the debate in the public is not necessarily a rational debate. No. So bringing in more scientific basis doesn't really help for most people. We need to find a new way, and I firmly believe, passionately believe, that this is about values, and it's about how we identify with our foods and how we actually are part of the food chain ourselves. And so the consumer doesn't want to be a passive sort of recipient at the end of the food chain. He or she wants to shape her own food chain in a way. And we need to have that debate, and also about what modern technology can play a role there, and where are the risk factors, and how willing we are to take certain risks in the area of food, but also in the area, for example, of traffic and other things. And we need to open up this food debate far beyond the GM debate. If you like, this is sort of genetics 1.0. Genetics 2.0 comes next, i.e. technologies that are quite different to what we're doing now, but that also involve doing things with the genes of our crops. So, for example, I mean, we heard this morning from Stephen Chu about shuffling as a sort of accelerated version of old-fashioned breeding, if you like. There's various forms of DNA editing being tried, where you go in and very specifically change one part of the genome of say, a cow or something, targeted. And though the people who are developing those technologies are paranoid about getting pigeonholed with GMOs, with transgenics, and they're saying, well, actually, you know, we're not bringing genes from other animals, we're being much more precise, etc. We need to develop a new conversation about the next generation of technologies. Is that possible? Anybody want? Tikki, this is quite relevant to particularly the questions about getting vaccines out of animals or antibiotics or whatever it might be that you mentioned. I don't know whether you have any thoughts about that.
I think perhaps one role that has been relatively neglected so far is perhaps the role of international organizations in all of this. And Louise, you were with FAO for a while. It seems to me that the debate's always between the researchers and the policymakers. So the idea of, you know, FAO, WHO, maybe UNEP, the Environment Program, getting together and, you know, forming a neutral platform, like a neutral broker kind of thing. These are all intergovernmental organizations. And yet I've never seen a concerted effort to try and use that channel to try and get at some of these, you know, issues. So that's just one thought.
Mm-hmm. Mm-hmm. Yeah. Well, shall we see if anybody here would like to join in the debate? The lady in green in the middle. There's a microphone heading your way, so wait for that to reach you.
Thank you. So thank you first for a great day so far. I'm Caroline. I work in 3D scanning. I have a startup. I have a question about 3D printing of meat. So they're starting to make artificial meat. And I'm wondering, do you think that making artificial meat might be, I mean, though there's a yuck factor, if it might actually help because we're that way removing a lot of animal pain and things like this, and that this might be one kind of artificial food which might actually be welcomed.
Yeah, Louise, you must deal with this in your book.
Yes. This is one of my favorite subjects. Okay, artificial meat grown from still, you need to have a starter animal cell, so it's not going to be a vegetarian option. The current cost is around $28,000 US a kilo, which makes it reasonably prohibitive for the short-term application.
Great steak.
But what is more important is that artificial meat does not do away with the other options that are far more feasible and far more logical. And there are two big options. One is to make animals more efficient in converting feed into food. And the Chinese have done a wonderful job in making sure that, for example, the uptake of phosphate from the feed actually is more efficient so that we don't have all the phosphate pollution from the slurry that comes from the animals. And also to reduce the greenhouse gas emissions from the stomachs of polygastrics like cows. But the other thing, far more important in the meat debate, is to me the substitution of animal proteins by plant proteins. Even today, we can substitute in most of the meat as we eat it. That's not the steak, but most of the meat we eat currently is meat in sauces or meat in some way integrated into the recipe on the top of your pizzas or whatever. That meat, you can substitute 30% by plant proteins, for example, from lupins, but increasingly also even from waste sources. We can retrieve proteins and iron, for example, quite easy from human excreta. We can use a rice bran and so on and so forth. We can actually close the cycles. Okay, yes, there is a yuck factor there as well. But even if we don't do that, if we only, the simplest option today, which is applicable and is applied today, is to use soybean protein instead of animal protein, put it in the sausages or what have you, and the consumer will not notice. And that, to me, is an enormously important application that is ready to be done and would reduce the use of meat already by 30%. We can probably go up very easily to 50% with some twisting and tweezing there and doing something about the texture. So my prediction on the meat consumption is that we can probably become more efficient quite soon. We can reduce the meat consumption perhaps as it grows up in the middle classes, as Dominic was just saying, and we can probably move towards lower species such as algae or other water-based sources to get the proteins and the things we need. There's only one proviso. Meat remains important. I'm not in favor of banning of meat. Young children, lactating and pregnant women and elderly people really benefit not just from the proteins in meat, but also from digestible forms of iron, for example, that you cannot get anywhere else. So the meat debate is a complex one, but I think the route towards artificial meat is probably very far down the line and not the most efficient one economically.
Just a thought about that. Steven Pinker has written this book called The Better Angels of Our Nature about how much less violent we are than in the past. And he goes through all these examples of things that we used to think were quite normal, like slavery or child labor or torturing animals, for entertainment, and how nowadays we would be horrified by that. So I said, okay, I said to him, what in 50 years' time are we going to be horrified that we once tolerated today? And he said, that's easy, meat eating.
Yeah.
He said, don't get me wrong, I love eating meat like anyone else, but our grandchildren will look back and say, you just kept animals with brains in cages and then killed them to eat them?
But
wouldn't it be wonderful if they didn't have brains? That's what you're saying?
I mean, shouldn't we go for just animals without heads, or even more? I mean, I'm a vegetarian, by the way. So, but shouldn't we go for animals without, or even more easily, possibly, genetically modified animals that produce continuous flows of endomorphins and don't suffer? I mean, the philosophical ranges there of our manipulation are far away. But to go into that debate, I think, is a little bit soon when we're not even there to accept GMOs in the first place.
So it was a great question, but it's premature. Right behind you, there's another guy.
Hi, my name is Ilmi Granoff. I'm an attorney and environmentalist. I wanted to pose the question about GM skepticism in a different way, because I am a GM policy skeptic, not a GM technology skeptic. And I feel that the panel has largely ignored one of the biggest justifications, although it's been brought up implicitly. Maybe the public is very skeptical about our policymaking apparatus. We have huge political economic problems, as one of the panelists observed, with how decisions are made politically about how food is produced, where decisions are made about which types of technologies are deployed. And so we're, as a public, rightfully very skeptical about how those decisions will be made in the future. And there's been a bit of a foot fault, as we call in sports, with GMs, which has entrenched that skepticism. Herbicide resistance is the obvious example of a huge foot fault in terms of the policy-making apparatus that makes us all the more skeptical about how the technology will be used. And so the real question is how we overcome that, rather than the 50 anecdotal and non-scientific examples we can give of really cool technologies that GMs could do, which is obviously not a very scientific way of going about discussing the benefits of GMs when we have to be asking, how is it deployed empirically? Once policy happens and the plants actually go in the ground.
So your point really is that if the policy was better, it would be acceptable. Who wants to take that on? I mean, is this a policy problem, or is it or do we think it's not a policy problem? Torbjörn.
Well, in Europe, certainly it's a policy problem to a large extent, because myself being a scientist, I think that if the scientific verdict were to come through into practical politics, that would be much better than the present process, where there is some kind of irrational opposition that is being allocated or sucked up by the political system and then used for various policy aims in Europe that have nothing to do with GM crops. For example, various green parties benefiting from being opposing to GM crops. And I think that the scientific landscape is pretty clear. There are no particular risks that can be attributed to the GM technology in itself. There are lots of risks having to do with big multinational companies monopolizing seed markets and various other kinds of problems that are not particular to GM crops but have become associated with GM crops, and that is a major problem.
Gentleman here with the yellow tie.
Yes, my name is Professor not in the GM area, but I am interested in food and in wine. And you have talked a lot of how you can prevent hunger from a gourmand point of view, but not from a gourmet point of view. If you take, for instance, a lowland cow, it will produce about 50 liters milk per day. But if you take a cow from northern Sweden, northern mountain cow, it will only produce between 15 and 20 liters milk per day. And if you make cheese for these milks, the milk from the mountain cow tastes much better than the cheese from the lowland cow.
Yeah. It's very interesting that we have to pursue quality as well as quantity as we go forward, and that perhaps one of the ways out of the GM debate is to show that it can help with quality rather than quantity. Louise, do you want to come back on that?
There is a complicated issue here. If you do double-blind tests between, for example, organic small-scale production versus large-scale industrialized production, for example, of tomatoes, contrary to what you would expect, consumers don't distinguish. The only distinction that occurs is an important one. That is when you change the variety. And organic agriculture has been very successful in harnessing some of the old varieties that had become in disuse, that had different tastes and different properties. So the challenge to me is to use some of these old varieties, whether it's of cows or of apple trees or what have you, take those culinary and gourmet properties and see whether you can use modern breeding to actually enhance the productivity of these. Because many, if you look at the example of apple trees, for example, many of those are not dwarf varieties that can have to be harvested by hand with significant costs and also labor risks. And some countries have been quite effective in getting these modern technologies of genetic and breeding and pruning systems into the old varieties, and even crossing some of the old varieties in the classical way with new varieties, so that you keep the culinary properties. And I think that is an interesting challenge. But it is not true, as you say, that low yield leads to better culinary properties. The reason why your cows in the mountains yield very little is because the conditions aren't just not good enough. And so we need to distinguish between the production circumstances and the genetic makeup. And going for the old varieties may be a very nice additional way to go for a new entry into the GM debate.
In red, there's a question.
And I think I'm quite happy to be here. It's a good discussion. I'm Ya Juan, a PhD student in Karolinska. Well, I'm from China, and we like to eat a lot of soy beans and soy products. But as we know that nowadays more than 90% of the soy beans are transgenic, and we import a lot of soy beans from US and Brazil and other countries. But the problem is, we in China we eat a lot of transgenic beans, but in US and in Europe, people generally are against transgenic food. So I agree with Professor Louise Fresco that the debate between GMO is largely about cultural conflicts, and maybe also the conflicts between rich and poor countries. I mean, we are now discussing whether in the future people will be starving, or how we can solve the food problem. But we never, well, not never, but we don't ask people in the developing countries what they want and what they are thinking. So I'm wondering, I'm wondering whether people in Europe, if they have the free choice to choose transgenic food and non-transgenic food, I mean, I think many people maybe they would like to choose the non-transgenic food because we don't eat them. We just think, oh, people in developing countries they need a lot of food, so it's better for them to eat transgenic food.
So in other words, we Europeans are quite happy to see people in poor countries eat it, but we don't want to eat it ourselves, as it were. Quick riposte on that from anybody? Tikki, do you want to come back on that? Let's go to another question right at the back, because it's a very interesting point you make there, but I've now got a lot of hands up, so I'm going to try and pull more people in. Right at the back, there's a gentleman been very patient with his hand up.
Thank you. Hello. I would like to ask the panel of their opinion on a particularly radical solution to this debate that has been proposed and that was recently presented also in Sweden at the Forestry and Agricultural Board, namely the proposal of Professor Pamela Ronald and her husband Raoul Adamczak to effectively combine GMOs and organic agriculture. After all, organic agriculture is about how you cultivate, not what you cultivate. Is this a sensible option? Would it work? And in conjunction to that, for instance, would using GMOs for other types of agriculture, such as forestry, perhaps ease up the debate, since it's not close to the consumers?
Well, just on the last point, it's interesting how we, on the whole, don't seem to mind wearing GM cotton clothes, do we? Or, I don't know. Anyway, Torbjörn.
Well, if you want to run an agricultural enterprise where you want to minimize the use of pesticides and recycle nutrients as much as possible, which is the idea of organic farming, then it's obvious to me that you need plant breeding. You need to create varieties of your crops that are particularly well suited for that kind of production system. So it's as easy as that. And if you choose, which they do, the organic farmers do right now, if you choose to refrain from using one very efficient breeding technique, that is GM technology, then you're going to be a loser in the long run.
Louise?
Can I add one thing on the organic debate? You're absolutely right, and I'm very pleased that you say that organic is about a process and not about the chemical properties of the end product, because that's a big confusion. There's no difference between a sugar molecule in an organic apple as opposed to an ordinary conventional apple. However, and here we come into the area of legislation and regulation, the current definition of organic in most European countries actually prohibits the use of GM, the legal definition. So one of the main challenges will be to redefine some of these issues and get into a true marriage, which I firmly also believe in. I think the key problems in organic agriculture also have to do with pests and diseases and things like weeds, asking for a lot of labor and manure. If we can resolve some of these problems by using GM crops that are, for example, more efficient in their nitrogen uptake, we can probably get a very successful marriage between organic and conventional agriculture. But we need regulatory and legislative changes.
I once complained in a restaurant because their menu said they serve no GM foods. It embarrassed my children enormously, you can imagine. Right here in the front.
Hello, my name is Aramia, and I'm a student at Gymnasium High School. And you said that there is no risk in using the GMO, but isn't the risk that we haven't used it for a long time? We don't know really what the possible effects will be. Isn't that the risk? And also, you said that pesticides used for GMO to get rid of them, that they have been giving a good result for the environment. But newly in the University of Delhi, they discovered something about that, the BT gene, that the toxins that it's giving, that the plant is giving out, is affecting other animals as well, not only the pesticides, which can affect the ecosystem and so on. You actually haven't mentioned anything about ecosystem. If you get rid of the pesticides, how will the ecosystem get affected?
Christiane, did you want to come back on the ecosystem point particularly, and maybe also on the BT point?
Well, I think in principle, and this is also true for organic farming, one tends to try to use crops which does not require much external spraying and other chemicals to keep it to give good yields. And I think in principle, making plants resistant, for example, with BT or with other natural fungicides or whatever, I mean, like in the potatoes, helps you preventing to put pesticides on the soil. For example, in the case of the potatoes, usually one uses copper, and copper is also used in organic farming, and this is very bad for the soil. And it is very bad for the environment to keep the potatoes healthy by using inorganic minerals.
And of course, BT as a spray was first invented by the
organic farming. You also use BT as a spray, meaning you kill all insects, not just the ones which would like to eat your potato or your corn. And I think in principle, you can also breed. Of course, you can also breed resistant plants, and you can also use natural plants, but they're not so well edible. I mean, this was also discussed this morning. I mean, usually plants have lots of protections in order to make them more resistant and more robust, and then we have bred away this. I mean, the traditional breeding has made apples with very thin skin because they're more tasty, and they make the muscle, and then we have bred away all the resistance the plant has naturally. And therefore, we have to protect it. We must protect the plants, otherwise we will not get yields. And this relates to what you said, which I think is the crucial thing. People don't know where the food comes from. They don't know that raspberries are not natural. Yeah. I mean, it's absolutely very unnatural to have these big raspberries, because normally they're eaten by everything, and you cannot harvest them. And this is what people don't keep in mind. And also what you said, that the resistance is against this mass production essentially and the industrialization of agriculture, but we cannot feed millions of people in big towns with just our front yard. I mean, this is impossible.
But you know, the interesting thing here is that there is a good case to be made for artificial raspberry flavoring in your yogurt, because it does not require the growing of raspberries, which require a lot of fungicides and so on and so forth. So some things are really counterintuitive, and we can only solve that by getting more information.
Gentlemen, yeah.
Hi, I'm Sohail Aziz Khan, teacher. I think we all are almost agree that we have a shortage of food, but it is from belly to brain. We have a shortage of that food, and if we say that for food we have shortage, then I can say that we are starving from our brain. Actually, how much of us know as much you people know? You see, I hear just different of examples. Like you have some skeptics there in Germany, and we heard even about India, and they have kind of third generation cotton where they can produce even seeds also. So it's means that if we keep working on it, so I think that we can solve these problems also. But the main thing is that we do need in this field that work should be carried on. But and the other things, as you mentioned, sir, that misuse of these. So of course we can regulate that. But to build that opinion, who can vote for something? So for that, we need more education. We need more information that people can know, that they can be build their opinion for or against. Otherwise, it's meaningless. If people doesn't know, you can ask me. I have just heard this is stereotype from one person. Oh, it's crazy. I'm eating fish or.
It's interesting what you're saying. I'm going to come to Dominic on this because I think the precautionary principle, which is behind a lot of regulation of genetic modification, is a fundamentally complacent thing. I.e., it's not recognizing the urgency which Dominic's been talking about and saying, actually, we quite like the technologies we've got. We don't want to risk something new in case it makes things worse. But status quo is not an option, really, if we're going to feed 9 or 10 billion people.
As you were talking, one other thing that was going through my mind, too, was also health. As you said, there's the food, and we don't understand as humans, and I'd be the first to say that, why we eat, what we eat, how we eat. But healthcare is the other one, and it's very interesting to see what's going on in the Middle East. If you look at Abu Dhabi and the diabetes, right, you just see, and it's happening in India as well, but just a rapid rise. And this is where I think genetics and understanding humans and how we absorb food and so forth, and then what we eat, I mean, it is very significant. And then to your policy point before, in Abu Dhabi, there isn't private choice about your healthcare records. They want the records and they want to understand it because there's a view, if we don't, we're going to be in huge difficulty down the road. And now someone would say we have to be I imagine in Europe that would not go down so well to say we want the medical records and we want to be able to do it. But I think when you start to see these, like healthcare costs is another one, going at 2 to 3% higher than GDP, it's related to food. We as humans aren't as educated as we should. Most humans don't know where their kidney is if you looked in their body and so forth. If they have one, yeah. Or two, yeah, hopefully. Yeah, sorry, yeah. But the point I'm just saying is I think just assuming everything is fine and we're going to get from here to there with this gap occurring where it is, I don't think we can underestimate the sense of urgency that's going on because the other consequences of not getting it right are even more severe.
That scare of unknown, you see, that is the problem. And it can be also solved by provide more information.
Yeah.
Thank you.
Okay, there's a lady back there on the edge who's got her hand up.
Hello, I'm Kate. I'm a student in the gymnasium. I would just like to add that there is enough food, it's just that people don't use it efficiently. Like, people are getting obese, and it's just greed that is causing the problem, in my opinion, because basically if you focus on politicians and basically any corporate organizations, they're out for their selfish means. So I personally don't think that there will be a problem with food. It's just that people want more than what they can get.
Anybody want to come back on that?
Yeah, I think, to be precise, we have about 1.8 billion people who are obese, but there's definitely a limit to how obese you can get. And you know, when you get beyond 4,000 or 4,500 calories per person per day, that really drops. I do not agree with you that obesity is a sign of greed. It's not as simple as that. We are all hardwired through our evolution to go for foods that are high in caloric density, that contain fats and sugars. And it's very difficult for each of us to actually resist that temptation. There are many lab studies that show if you give people unlimited food, they will continue to eat. In the past, this was regulated through all kinds of rules and regulations and taboo and religious rules. For example, in the Middle Ages in Western Europe, there were 166 days of official fasting. We do not have days of fasting anymore. And the individual has become responsible in Western countries for his own food intake. And I think it's too easy to say that, you know, if we would do away with the greed, obesity would disappear. This really requires a fundamental societal change for us to deal with abundance in general, whether it is in cars or in goods or in food. That requires an educational process which will take a generation or two.
Yeah, just to build on it, I would say too, I mean, I think your point about waste, I would agree with. There's more. Again, if you think about in many developing countries, in India, about 30 to 40% of the food is wasted before it even gets to the market. There's just not the transportation infrastructure. And then, as I said, on the other side. So I think there's more we can do even on that front. Putting in cold chain and infrastructure, roads would be a big deal. But that said, when you think about the number, 1.8 billion people that just want to eat more and not eat obesely more, I don't know how you get from A to B just by saving on the wastage side or the other pieces. I think there'll still be a gap.
Torbjörn, do you want to?
I just want to comment on the idea that agriculture, let me put it this way, agriculture is not only about producing food, and in the future it will be less so. As you were pointing out this morning, we have at our disposal photosynthetic-driven chemical factory that can be used to produce food, energy, pharmaceuticals, polymers, replacing fossil fuel, etc., etc. So there is always, even if we don't waste food, and even if we can feed the population of the earth, there is always a need for increasing productivity, because we can always, in the future in particular, we will be able to always use all available land for producing commodities that are good for mankind. And to you, I would like to comment that, no, we didn't mention the word ecosystem, but of course, in the back of my mind, being an ecologist by training, is all the time the idea that sustainability has to increase, and the environmental concern has to be central to our thinking about agriculture. And that's precisely why I believe that science and technology, including GM technology, needs to be included in this enterprise.
We have 4 minutes left. And
Pretty good talk, wasn't it? Yeah.
We have 4 minutes left and we have 5 panelists.
You smiling.
So I want each of you to say in less than a minute, in 45 seconds each, what you think the most important takeaway for this debate is. Louise, do you want to go first?
I would like to say something about risk. We are risk averse in the middle classes. I think risk has always been part of our human history. We have learned so much. We have made many mistakes also in agriculture with pesticides and so on. But the key characteristic of humankind is that we've learned across generations, and we've learned from our mistakes between generations. And let's not be afraid of taking risks. Let's not sit back and wait for things to happen. Risks are always there. They were there when we first introduced the automobile. That was a lethal weapon without brakes, without lights, and so on. We've learned to deal with it socially in terms of getting a code for how you need to drive, but also technologically by making cars safer. I am sure that if we let science go its way within all the regulatory frameworks that we have, we can actually do well and learn from our mistakes also in genetics.
That was more than 45 seconds. Tikki.
I'd just like to comment on what was raised before about the shaping of public policy, especially in the developing world, where 3/4 of people live in low and middle-income countries. And I would really like to see some effort made. Are there lessons to be learned from what's happened in the developed world that can help to shape public policy in the developing world? Very few developing world countries have the luxury of someone like Stephen Chu, who's a top scientist at the same time a policymaker. And that's part of the problem in the future.
Torbjörn.
I'll be very short. Science has always been an important driving force in developing agriculture, and let's make sure that it will continue to be so.
Christiane.
I think the environmental aspect is very important, that we keep our cultivated land in the most sustainable manner and with the highest efficiency of producing crops, but also leave other land untouched or renature it even, and try to get the GMOs to cultivate land which is now not fertile, for example, because of salt or droughts or other things. It was a bit rough, but we have covered many of these things already before.
Dominic.
I just simply say education. I think it's back to the point the gentleman made. Educating the consumer to understand how this works, I think, will be extremely important.
Well, we've got 1 minute left, so I'm allowed a last word. Thank you all very much indeed for coming. Thank you for a wonderful debate. If I would just leave you with one final thought, it's that 2013 will see, we think, the rollout of golden rice, the technology developed in the 1990s by Ingo Petraikas in Switzerland. A fantastic technology, in my view, that will help deal with the 500,000 kids who die every year for vitamin A deficiency, and that will be probably the best way of getting vitamin A to these kids, and is a non-profit project. I think how that is handled depends on whether we can reboot this debate. So watch this space in 2013 if it does happen. And thank you very much indeed to this wonderful panel for a fascinating conversation. Please join me in thanking them. We now lose all 5 of our panelists who go elsewhere, and we get a new 5, but I don't change. Sorry about that. And we changed topic to basically how human genomes interact with the environment rather than how plant genomes interact with the environment. So the nature-nurture debate next.
Då börjar det bli lite sådär van.
Absolut. afternoon, everybody, again. It's me again. You've mostly seen me before. Welcome to panel 2B, an entirely fresh, new and exciting panel. And the question we're going to address, if I can remind myself of it, is genetics and nurture, understanding the interaction between genetics and environment. Has genomics finally resolved the nature-nurture debate by showing how our genes are actually at the mercy of experience through being switched on and off by transcription factors? Is epigenetics a revolution or just a deeper understanding of the genome? Has the world realized yet just how much less deterministic genes are than we used to think? And can we find environmental interventions for genetic disorders and vice versa? That's Jean Braca, and has been a pioneer of using genome sequencing to identify the victims of human rights abuses. Helga Nowotny is the president of the European Research Council and a distinguished social scientist. John Dupré is the director of the Genetics for Genomics in Society at Exeter University in the UK. And finally, we have a former birdwatcher on the panel, James Watson. So, Bruce, can I come to you first and say, how has infectious disease affected the human genome over evolutionary time?
Well, let me start by saying that I'm also a former birdwatcher.
Well, I think that makes four of us, because Marie-Claire's a birdwatcher.
All right.
Anyone else here a birdwatcher? Should we talk about birds? Anybody want to talk about birdwatching? Birdwatcher, put up your hand if you're a birdwatcher.
All right. Oh.
Roll on. Okay.
What are the chances? What are the chances? To answer your question, I think that you started off very nicely talking about we have genetics, we have epigenetics, we have environment, and there's some interplay that determines essentially what happens to us. There is real predictive value of genomic information. It's not absolute, and there are those other categories. Where our genome is concerned, no doubt it's been influenced hugely by one aspect of the environment, well, really by all, but by one in particular that I talked about a bit at lunch, that being infectious disease. Because it's such a powerful selective agent. It is responsible for about a quarter of all human deaths, and for the most part, these are deaths that occur prior to reproductive age. So at least recently, infection has been the biggest selective pressure with which we've had to cope. If you think about it over the long haul, from the dawn of evolution of multicellular organisms, it brought our immune system into existence. First the innate immune system, then about 450 million or 500 million years ago, the adaptive immune system. And these are so complex in their operation, they constitute such an effective machine for checking the progress of infection that they depend really on thousands of genes in all probability. Moreover, thousands of genes respond when we have an infection, which represents an extreme example of environmental change. And so, all things told in that direction, I think that infection and the host response represent really the premier example in the short term of interaction between genes and environment.
Marie-Claire, how does the citizen scientist ask the right questions about gene-environment interactions and things like that?
About gene-environment interaction in particular?
Well...
No, fair enough. It's a good example.
Whichever example you want to choose.
Right.
But I think it's the coming at it from the citizen scientist point of
right.
view would be nice. But whatever you want to start off on.
Yeah. Let me take a particular example that goes back to my youth as a scientist. I was a graduate student in Berkeley in the 60s and early 70s when, those of my age will recall, there was a tremendous controversy about the role of genetics and environment and intelligence, which was soon cast into a racialist perspective by some of my colleagues at Berkeley. And we, as progressive graduate students, felt ourselves in a situation where we really had the necessity of taking a stand because we knew the genetics, we knew the statistics, and yet we were 20 24 years old, in an environment where the people with authority and power were on a very different side from us. Not that we weren't in a progressive town, but this particular issue was dominated by people of a very different stripe. And so the way that we as a group went about it was to study it. I mean, we said, what exactly is the data? What exactly are the claims? What exactly is the literature that actually bears on each of these claims, and how can we put this together? And it was enormously successful. I mean, applying the scientific method to a question which was, in my view, a fundamentally political question, social question, although it was phrased by those proposing it as if it were a scientific question. But applying the perspective that we all know as scientists toward demanding that one actually have evidence before making a statement, and looking into counter-evidence can be a very effective approach. There are, I fear, all too many questions that come at us. I've recently been in correspondence with Mona Saif, a citizen journalist in Cairo, who works on BRCA1 in her paucity of free time at present. And she's confronted with the situation of what to do in a revolutionary situation in her own country. The fact that she's an expert in BRCA1 in Egyptian women does not inform her about what to do in Egypt. But the fact that she can think well as a scientist, that she can formulate the question, that she can gather the evidence, and that she can state it in a linear way, that does empower her. So I think it's a matter of using common sense, informing ourselves about what is being claimed, what the data is for or against it, what the other data is, and then bringing it to bear in the same way that we would on any scientific problem is absolutely the most likely to be effective.
Thank you for that. Helga, how do we escape the determinist trap?
Well, let me follow up on what Mary just said. I think there are ideological issues that sometimes come up in such controversies, and I lived through similar times. I was on the East Coast in New York at that period. And I think what needs to be done is to unravel the ideological issues from the scientific issues. And in terms of your question, the genetic determinism, this is something that, unfortunately, in the exuberance of, many scientists gave the impression around 2000 and before. Now we will find first the genes, 100,000 genes, and it turned out to be far less. And there was this very strong tendency to come up with causal statements that in the end just were without any basis. And unfortunately, it takes time. So also the media sometimes bring the message across in a distorted way for various reasons. And I think now the time has come with epigenetics, where you bring in again, the environment, but what do we mean by it, nurture and nature? The terms are being changed. And therefore, I think this is a good time, a good opportunity to get it right this time.
John, I don't know about you, but I feel that genes seem a lot less scary now we know more about them. Do you think we're learning to understand that genes are devices for interacting with the environment rather than puppet masters?
Absolutely. Yes, so I suppose that one way to look at it is that we're moving from a two-dimensional view of the genome to a four-dimensional view of the genome. So one of the things so epigenetics, in a sense, gives us at least a third dimension by realizing that the genome is a physical object that has a shape, and the shape changes. And as the shape changes, it does different things. The shape changes, the epigenetic influences that create this object change through the development of an organism. So different parts of the organism have different genomes. Some of that is very much canalized in the development of the organism. Some of it's highly sensitive to the environment in which the organism develops. So the genome is absolutely not a puppet master. It's just a crucial link in a complex chain, and I guess I would say a chain of, to sound horribly fuzzy, but of circular causality. So there's, and I guess one of the things that we also need to get beyond, and it was a wonderful ladder, but the central dogma, the idea of DNA causing RNA, causing proteins, never the other way around. This is completely gone with epigenetics. We now know all of these countless RNAs and proteins that affect what the genome does, how it configures itself, how it develops over time. And as I say, I think it was a wonderful ladder because it enabled us to concentrate on certain questions, but it's definitely time to kick it away and try and embrace a dynamic four-dimensional genome.
Jim, is your success in both science and life the product of nature or nurture?
Yeah, let me just give my background. Since birth, I've been an Irish Democrat from Chicago. Okay, so there no doubts as to what I think of Republicans. Okay, so I've not changed for a moment. Second, let me say that the word epigenetics is used for a lot of crap. Yeah. And it is used by people who don't like genes. And it sort of implies the random influences, which whether from the stars or something, that means that with the same set of genes from birth, we can have different fates. There's virtually, a few genes work this way. For the most, it's not. I mean, we've known for 50 years that gene expression varies depending on the environment. If you have a different food source, different things will come up and down. So gene expression is always a function of the environment. But it means that genes are less important. I mean, the people I find who really like epigenetics are hardcore left-wing people. Who, yes, make no doubt about it.
Or Lamarckists as well. The revival of Lamarckism, which is...
Yes, it's a form of Lamarckism, with really very little evidence. Now, there are some strange things in genetics, of which I spoke to you earlier. One is called allele selection, which is where supposedly diploid for all genes. But for many of the genes, only one of them is expressed. So for many of our genes, we're effectively haploid. Now, I think that's a device to speed up evolution. But it does mean that genetics can be really messy. Because depending on what gene, the second generation doesn't have to be like the first. So it's a sort of phenomena which will complicate, going through family pedigrees.
Just on, if I could stay on epigenetics for half a second, but we mustn't get stuck on it forever, and I think Marie-Claire might be able to put me right or wrong here. I've sort of come to the conclusion after reading the literature that the evidence for epigenetic imprints surviving mitosis is very strong, i.e. that something that happens very early in your life, if prenatally, can have an influence on how your health turns out much later in life. But the evidence for epigenetic imprints surviving meiosis is very much weaker, and that apart from the Overcalyx study here in Sweden and the agouti mice, there's very little evidence of transgenerational epigenetic effects. Is that right, or am I being a bit simplistic?
I think it's correct. I think Bruce can enlighten us more. Why don't we go to Bruce first?
Well, I think that is correct, and I think there are rather few genes where epigenetics is transmitted through meiosis, but it's those exceptions that are extremely fascinating, and I don't discount them, and I don't doubt that there might be more if people look for them. If we take,
it's the vast majority. I think it's and.
Are you talking mainly about
the people who talk about it?
Gender
I think
imprinting.
it's really just, they're using the word epigenetics to describe gene expression, which is, of course, under genetic environmental control.
I would just propose to speak a little more broadly. When we say epigenetics, we can be thinking about the fact that a liver cell is phenotypically very different than a brain cell. We both agree they have the same genome, and yet there are certain genes that are irreversibly repressed in one and not the other, and vice versa. And this is fundamentally true, And it's also not all that well understood. It's not due just to the enforcement of transcription factors. It's changes in chromatin, and there is a code there that we don't understand well.
Let me take this on, Jim. I think I agree with everything that's been said by Bruce and by Jim, and I think that there is a danger, and I think this danger is particularly acute in Europe. And I'm not sure why. It might just be because people are more accustomed to discussing intellectual issues here than in my country. But
having complimented him, Europeans
now I'm about to insult the entire audience. I think we have a real semantic problem, which is on the cusp of becoming a philosophic problem, and then is dangerously on the cusp of becoming a political and social problem, and it goes like this. Epigenetic effects are certainly real. Imprinting effects are certainly real. There are examples, a few examples of meiotic transmission that are real, by and large not. Everything Jim says is also correct. That is, if we use the word epigenetics, which is a term of art, that is, it has a narrow sense definition in our field. If we use it more broadly, we risk running into confusion. And what concerns me is that we will be sloppy about demanding evidence of epigenetic effects. I think we have to have the same standards of evidence for epigenetic effects that we have for genetic effects. And all of us as progressive people were very good about demanding evidence for genetic effects, and we're very good about saying there is no evidence for genetic determinism here and here and here and here. And I think we must be equally rigorous at the level of epigenetic effects, because if we are not, it will come back to bite us. And I think that we have not been. Particularly when I come to Europe and I discuss these things, I find a sloppiness in the use of the term epigenetics that I think does the field no service. So now that I have insulted everyone, I apologize for but I think we need to clean up our act on this one.
John or Helga, do you want to come back on this at all before we go on to another topic?
Just momentarily, I feel a certain weight of expertise bearing down on me at this point.
That's right. We'll get into an epistemological argument soon, and you'll have me.
But I'll just make one point. And of course, I can't disagree with the importance of trying to be a little rigorous about this. But I think this question, we perhaps overestimate the theoretical, if not the empirical, significance of this question about meiosis. Because, the transmission of epigenetics could happen through simply, kind of preservation through meiosis. It could also happen through the passage of cytoplasmic chemicals that can recreate the same.
This is show me the money
yes.
in America.
This is clearly an in principle argument. I would agree. But there's also, beyond that, even to a further level, and this is, of course, the horribly oversighted, no doubt, work by Meany and his collaborators, but very fascinating. Yeah. But what it demonstrates, again, is something that we don't know how widespread it may turn out to be, but you can actually transmit epigenetic effects behaviorally. And
there are examples, yes.
There are examples of that. So
that's in rats.
Yes,
in rats.
Yeah.
Yes. Mm-hmm. But so it seems to me. So I guess as a philosopher, at least I'm entitled to look at demonstrated possibilities, consider what they could imply ahead of leaving it to people like you.
Just to clarify for the audience.
Oh yes, I'm sorry.
If pups are licked, pups are licked by their mothers, they end up socially more well-adjusted than if they're not. Is that
therefore more likely to lick their pups and therefore create the same epigenetic effect.
So were you licked by your parents? If so, you're...
Is it
nicer
epigenetic?
People.
Not in our
Well, what was the supposed fact that you ended up more socially well-adjusted if you did what?
If you were licked by your mother.
Moving on quickly. Sorry, it's my fault. Helga.
In the world of rats.
Yes.
Helga, I'm sorry, I'm going to lose control of this panel if I'm not...
apart from licking rats or children, I just want to make the general point that whatever technical language is used and concepts that travel into wider society, they change their meaning. There's no way of controlling it. And of course, then you have to face the translated meaning. Something similar happened outside of the life sciences with the word chaos theory. When this came up in complexity theory, people said, wow, finally there is something happening that vindicates our experience, which is that life and the world we experience is not one of linear, straight line leading from A to B, but we do have this complex, non-linear dynamics without being able to put it into a mathematical formula. And nevertheless, there was this response. So what you feel in Europe now, and I think your observation is correct, there's a lot of, public acceptance.
It's all the rage.
It's all the rage. But this is what I think presents an opportunity. After we went through this genetic determinism and also the ideological split between nature and nurture, and you described it well, I think now this openness presents an opportunity for you to come in and to say, look, on the technical level, this is proven. There are interesting examples. There are, I think I also read about the Norwegian studies of the nutrition of grandmothers affecting the health. So things like this, they may be common, they may not be common, but nevertheless, there is something there where you can bring in the public on your side.
This is slightly changing tack, but it's still on the nature-nurture question. When I wrote a book about this, about the history of the nature-nurture debate, it sort of dawned on me that one of the reasons these kind of debates get so polarized is because people read their friends' accounts of their enemies' arguments. They don't read their enemies' arguments, they read...
Right, very dangerous thing.
And we all do this. I mean, we know we do
but
this.
This comes already when you have the polarization.
Yes.
But there's a time before the polarization.
When you can prevent that happening.
15 minutes.
Is this... is this, speaking to a philosopher, is this something that you recognise or can think about, John?
Sorry,
the fact that people polarised by, as it were, getting distorted versions of their enemies' arguments.
No, absolutely, and of course, I mean, there's another very simple side to this problem, which is, the scientific paper published every 4 seconds. I mean, how are you going to choose what to read? And I guess to some degree, and I guess perhaps one of the more optimistic ways of looking at it is not very optimistic, is that the best you can do is hope that people will, construct the best arguments by reading the, as you put it, their friends' papers about their enemies, and eventually the best argument will win, we hope. But I also agree there's very important to see these things emerging and trying to get some discussion.
Mary-Claire, you want to come in, then Jim.
Yeah. Let me take an iconoclastic position for a geneticist, and Jim is going to disagree with me.
But don't do all the speaking. I want to speak as much as you. But go ahead. Just say your piece and justify it.
Okay. My iconoclastic position, which I'm being straight person for Jim here, is that genetics is effective around the edges, that our goal is to identify, prevent, treat illnesses that have a major genetic component. But that apart from that, for daily life, for well-being of children, for success of children, genetics has virtually nothing to do with it. That it's a matter of free will, it's a matter of choice, it's a matter of hard work, and that we are really not part of that story. Let me posit that, and then Jim, you take me on.
I want to say that I want to explain how Matt Ridley and I met. We met at the Cheltenham Literary Festival, where Matt was moderating a debate between myself and Stephen Rose as to whether mental disease was genetic. And Rose gave the argument that it was entirely due to capitalistic stress. And if there was no capitalistic stress, there would be no mental disease. And, all I could do was say twin studies and things like that, which made me think. But, what came out now, the Cheltenham Literary Festival is filled with middle-class people who read. And it was quite clear that there were 10 to 1, like what Rose was saying. The middle class does not like the fact that they're limited by their genes. Or they're determined. They want the freedom, to be perfect if they do everything perfect, okay? Mm-hmm. And so we are dealing with a world where you might think they agree with us, but, you just have to move toward the social scientists. And they're against us. Okay, they would like society to be freer than I think it is. That's all. And so that's how we met, was my realization that the middle classes, or at least the British middle classes, I don't think the American are any different, they're really uncomfortable with genetics. Now, that's my first argument. Then the second is, so what we've done, is we went back, we finished the Human Genome Project, and we've shown that schizophrenia is without a doubt genetically determined. There's just no doubt about it, okay?
Well, and, partially. I mean, not 100%.
No, but...
okay, sorry, yes.
Right.
Yeah.
But it's looking like, genes are there. And so then the second is, these are bad things. Now, can capabilities be due to genes? Okay. And I'll give you a case which looks like it's going to be the case, though we haven't found the gene. It is, again, I told you, musical prodigies, the ones who play instruments very early, have one common trait. It's revealed on their IQ test. They do not come forth as, on the whole, more intelligent than other people, except for their working memory. They have incredible working memories. So they're in the 99% or 99.9, okay? And so this is a case where if we find the progeny, people with a very good memory, we can then, and if their parents have normal memories, we have a good chance of finding genes behind this perfect thing. And so, to me, it's a very exciting thing to do. I'm sure it'll be done in the next 5 years. It could be done in the next 2 if you just got out about it. So then we will show that one positive trait.
It's a real phenotype.
It's a real phenotype, and that it's likely that differences in working memory are in some sense under control of genes. That's all. So
fair enough.
Slight change of tack again. I want to ask Bruce this question. Very interesting book I read recently called An Epidemic of Absence, which explores very skillfully the theory that a lot of autoimmune and allergic diseases are down to an absence of parasites in our environment. The idea that because we're not encountering worms or other parasites early in our lives, our immune systems therefore kind of overreact. And there seems to be all sorts of good evidence for this. But what it means, of course, and he brings in even autism as an example of something that may well be it shows exactly the same epidemiological patterns as asthma and other things, having increased in urban populations among affluent people, in males more than females, etc., etc. And what it means, of course, is that there are fates out there that are determined early in our lives, which are not genetic in a sense, they're environmental, and yet they're just as deterministic. First of all, Bruce, on that idea, do you think there's a lot in that idea, or do you think that it's barking up the wrong tree?
You're talking about something we refer to as the hygiene hypothesis.
Roughly speaking, yes.
And I would say that it has good correlational backing. but that is something very far short of proof.
Right.
And one might imagine that there are also nutritional differences in places where there tends to be more of a type 1 versus a type 2 CD4 response and so forth. Right. So it's really hard to be sure on the basis of these epidemiologic studies just what is going on.
Right, right. But if you get something like just eczema or asthma or something, you've got it. You know, that is part of you, and it doesn't matter whether it comes from a gene or a lack of a bug or a nutritional thing. It's a deterministic thing, but that doesn't make it uncurable, does it?
That's correct.
So the equation between determinism and incurability is one that's in a lot of people's minds, and it's not right.
I think there may be something else involved. I mean, undoubtedly, this is work in progress. We are far from understanding everything. But if you ask, you know, why do feel people so constrained if they hear the word genetic?
Or determined. Yes. Mm-hmm.
Or determined versus environmental. And I think the reason is the irreversibility.
Yes.
With genetic, you have the feeling, you know, you cannot go back in time and change it. With environment, you can move to another environment. Whether it works or not is another question. But at least environment gives you maybe it's an illusion, but it gives you the impression. First of all, you can change the environment, you can make it somewhat better, and you can change the environment, you can move somewhere else.
And of course,
so this, humans, they want to have more degrees of freedom.
Yeah.
It's a deep-seated urge. Whether it works or not is something else.
In some cases they do, some cases they don't. I mean, if you take
I agree.
dyslexia or homosexuality, on the whole, people are pleased to know that it is a deterministic thing that is not, as it were, their fault for doing something.
If you like
life.
your condition, you have no reason to reverse it. I mean, it's as simple as that. But you know, if
dyslexics probably don't like being dyslexic.
No, but
they like it recognised that it is.
Yes, because
not just being
if it
stupid.
is not recognised, you're just a stupid boy.
Yeah.
While if it is recognized, at least the teacher says, you know, it's not your fault, while being stupid apparently is.
Genetic or environmental.
I agree.
Right.
I
mean, that's an orthogonal issue.
I agree.
Right.
But, you know, before you come to attributing it, I think you have to realize why people react in a different way.
Mm-hmm. I wonder if this is a good moment to ask for a show of hands in the audience. Ask for hands for questions, because we've got 35 minutes left. So let's take a few questions from the audience and see where that gets us. There's a man with a stripy thing right in the middle, but as far away from the microphone as you can get, but it'll get to you eventually.
Thank you. My name is Paul Hudson. I'm from the Royal Institute of Technology here in Stockholm. I have a question about the microbiome, the bugs and everything living in our bellies and whatnot that seem to be becoming more and more important because there are so many more genes that are bacterial in our bodies than are actually human.
Who wants to take on the microbiome? Bruce?
Well, do you have a specific question about it, or just general comments?
Yes, of course. I'm thinking of recent studies where people have found that high intake of antibiotics as children, or as young mice probably, can change the composition of the bacterial flora, and then that results in a tendency to become sick later on.
So that is true. There's a lot of plasticity to the microbiome. Treat a young mouse, or a mouse of any age, with antibiotics, and to an amazing extent, it will change it, and it doesn't really go back, at least not very fast. The consequences of that are not really all that clear and solid and cut and dried. One can't say that the mouse is less fit in this way or that way, but the possibility exists. And, of course, this is one aspect of the environment, if you want to talk about it that way. None of us is born with a microbiome. We all acquire it, and it tends to be quite similar within families, but not absolutely so. There's an element of chance involved in just how you become colonized.
And things like the polio epidemic came about because people weren't getting colonized by the virus early enough, and so they were getting it at a more vulnerable later age. That
at least is the general thinking, that it's a much more serious disease if you have it when you're in adulthood.
Right. John.
I think there's something that's very conceptually interesting about this, which is that it actually, I mean, Bruce said it as part of the environment, but I think it actually starts to break down the distinction between the organism and the environment, because how obligate does a symbiont have to be before it becomes part of the same thing? I mean, we were very familiar with lichens and corals and things that we quite used to calling them, giving them species names, but we haven't. We're really only just conceptually, I think, adjusting to the fact that we are actually a complex symbiosis, and I don't think it's at all obvious that we should think of these as part of the environment, or at least if we should think of the boundary between ourselves, what's inside and outside, as much less clear-cut than we once did, which I think is very interesting. I mean, obviously, changes to the microbiome can actually be environmentally responsive changes to us. I mean, and so I think it changes our view of who we are in rather important ways.
Do you think it has a relationship to the argument about determinism?
Well, I think so. The argument about determinism, there's a big determinist argument, which I don't expect we want to go into here. Then there's the ex-determinist argument. And I think if the argument is, should we be genetic determinists or environmental determinists, it then forces it's another thing that adds weight to the argument that we certainly should be neither.
We should be neither.
That we should be as interactionists. We should understand that
an American argument,
yes,
if there ever was one. We control our fates.
Well, I lived there for a long time.
There's a question right at the front here.
So there's been a lot of talk about inherited mutations, but in cases like autism and schizophrenia, there's a growing body of evidence that there are brand new mutations occurring with each generation. How well are we doing at integrating that in our thinking about these issues?
That's a very nice point, because it's genetic but not inherited. Mary Claire, I think that's one for...
Right. I've become fascinated with this question for the last few years in consequence of a challenge put to me by Jim. He does this all the time, so today's behavior is not out of the ordinary at all. He says, you need to think about this. You're not thinking about this well enough. And he said the big question is, what are the causes of schizophrenia? What are the causes of autism? And it got me thinking again about the difference between what is genetic, what is familial, and what is inherited. And we tend to blur those three words, but they are quite different. Autism and schizophrenia are very, very frequently genetic, and autism is rarely inherited, and schizophrenia, of course, can be, but is more often genetic but not inherited. There are certainly phenomena that are inherited but not genetic. Money, for example, right? It's inherited. It's familial, it's not genetic. So these three concepts are completely different. So once we understand that basic principle, if I weren't in the presence of a philosopher, I would say that basic philosophic principle, we can go about testing hypotheses for each. And the geneticist can establish a hypothesis about de novo mutations responsible for autism and test it. We can establish a hypothesis about de novo mutations responsible for schizophrenia and test it. That is being done. The answers are positive. And that's, I think, a tremendous advance. In the sense that genes have been identified for autism. There were 3 excellent papers published in Nature within the last 3 months or so from 3 different groups, sponsored by Simon's Foundation and some of the autism foundations, that established in individual cases of autism, by comparing the genomes of children who were affected to the genomes of their parents, that there were de novo mutations in these children in genes that are established from independent lines of evidence to be critical to brain development. We have some brand new work in schizophrenia in this same area. It's not published yet. It's just now in review. So please be careful about what you say about this if you are writing. Right? So this area establishes for many persons who are ill genetic underpinnings of the illness, but without their being inherited. I consider this completely orthogonal to the question of whether they are treatable or not. Of course they're treatable. An illness is treatable regardless of its cause. One has to know what the treatment is.
Jim, does that surprise you if de novo mutations are turning out to be important, particularly in mental disease?
The de novo are important.
The de novo mutations, i.e. mutations that appear spontaneously for the first time in people, are proving to be important. And what does it tell you about that?
Slappy, we have a mentally ill son, and my wife and I are not mentally ill. So, the likely guess was it was a new mutation. Now, I think the interesting thing is whether, the mutation frequency goes up with male age, and how important is that? And, are you really morally irresponsible if you father a child if you're 70? And knowing that you're moving up into a sort of scary range of mutations.
You're irresponsible in all sorts of ways, but morally too.
Irresponsible, certainly to the mother of the child, because you're going to die and she's going to have the child.
Helga, do you want to come in? No.
So I think, I wasn't surprised.
We got one here.
I learned recently that your phenotype can affect your alleles, and they can be passed on to your offspring. But I'm not sure who said it, I think it was Miss King, that your environment can't affect your genetics. Said that you can change your environment, but...
I think we're back to epigenetics here, are we? That things that can happen in your life can affect your children's genes?
I would interpret the question in a different way.
Sorry.
Okay.
Mostly because I avoid using epigenetics unless I actually have direct evidence of methylation or acetylation or something like that. Let me interpret it in a different way. And that is the question of environmental assaults on the fetus during gestation. If we take the example of the Dutch hunger winter at the end of World War II, a period of famine between roughly October, November of 44 and May 7th of 45, in the 6 cities of the Western Netherlands that were put under blockade by the Nazis. The birth rate during that period, of course, plummeted. The death rate, of course, peaked. But what I want to speak to is the fact that neural tube defects were fourfold higher amongst children who were in gestation, in the first trimester of gestation during that period, than they were before or after, or in the eastern part of the country, which was not under blockade. And in studies done 30 years later, the rates of schizophrenia were twice as high among individuals who were in first trimester of gestation during the famine than in other parts of the country or before or after. Now, those are beautiful epidemiologic studies. They are not molecular. I would posit that a good possible explanation is that one thing that happens to the mother when in a period of famine, in a condition of famine, is that she's folate deprived, and that her ability, therefore, to repair, the ability of the fetus, therefore, to repair mutations that occur is suppressed. I have no evidence for this from the famine data, but I think it's a reasonable hypothesis. In the same way that Jim points out that paternal age is permissive for a large number of de novo mutations, I would suggest that your suggestion, with which I agree, that the environment of the pregnant woman, it also under these kinds of stresses becomes permissive for a large number of additional de novo mutations.
But then I learned that they were permanent as well.
Say again?
the alleles were permanent and they would be passed to future generations?
Oh, of course. I mean, a de novo mutation is a de novo mutation. If it is in the germline of the individual and then it's passed to the child, it can be passed on. It's different than cancer.
That wouldn't be true of folate deprivation, though.
My hypothesis
yes.
is that folate deprivation precludes proper repair of mutations that would occur anyway. I mean, half of us have been pregnant, and we are aware at some level that during that time, mutations can occur as they can at any other time, but you have a fabulous repair system in place, but you don't if you're folate deprived. I'm making this up. I mean, there's no direct evidence for folate deprivation being the cause of the increases in schizophrenia and neural tube defects.
I think we have a question from online. Is that correct? Yes. So if we can have the microphone here.
Yes, I have a question from an online audience from India, and this viewer asks, there are innumerable amounts of mutants present in the environment. How can we make our body more resistant to various mutagens present? And then he also continues to ask, can we make our DNA repair system more powerful?
So how do we resist the innumerable mutagens in the environment? Is that what?
Yes.
And how do we make our DNA better repaired, as it were?
Yeah, can we improve our repair system?
Somehow this has fallen on me, and it's something I know very little about. I know, of course, about many different environmental mutagens. There are some that alkylate DNA, and then one has mismatch repair afterward. There are some, like, for example, ionizing radiation, that will tear out whole chunks of DNA, and that's a very different mode of damage. And, of course, there's UV, which is still a different mode of damage. And I wouldn't hazard a guess as to whether there's a universal way to prevent all of that. There might be selective ways to prevent mutation, to prevent oxidative damage, for example, but I'm not at all sure that the methods we usually use, the antioxidants that people take in vitamin supplements and whatnot, are really capable of doing that, particularly in the germline.
I was talking to Jim in the bus on the way here about exactly this issue, about whether or not by suppressing by using antioxidants, we may be encouraging cancer, to put it bluntly. Do you want to take up the story, Jim?
Well, oxidants seem to be the way most cancer cells are killed by medicine. And so, antioxidants are probably why the primary mechanism of resistance to drugs. So if you could inhibit the antioxidants, the oxidants would work better and you could kill it. So that's why. So if I had cancer, I wouldn't worry about another mutation. Now, you might if it's a 3-year-old child, so, I'm making a difference. But at 70 years old, I would just get rid of my cancer and not worry about whether I'm doing that. So.
But the question of the child, the question of how to treat childhood cancers really is an important one in this context, because you are, of course, introducing.
But you see, our current treatments which work often for childhood cancers lead to secondary mutations and people getting cancers as adults.
That's an interesting point. We have a question right at quite far back. Yes.
So, taking on what was just said, we live in a world that in which we take a lot of vitamin supplements and mineral supplements. Students take supplements when they have an exam to concentrate better on the exam. And even the milk here in Sweden is supplemented with vitamin D. When we check the package of milk, we see that it's not just milk, it's actually vitamin D that they put extra inside. And there was an article in Times last year in which a reporter started taking vitamin supplements for a long period of time. And reported if he felt an effect on himself. What he said is that you tend to have a worse diet because you take the vitamin supplement, so it is a double-edged sword. And there's also the question if the companies that produce these supplements, is there a commercial interest or is there really an effect of these supplements on our genome? so the effect of the environment, because most of these supplements are actually, they say on US, they say that it's not FDA, it has not been tested, and the FDA acknowledges that. So to what extent, and this is my question, to what extent do these supplements have an effect on our lives and all this food that we take?
Let's ask a philosopher.
Well, just a very facetious answer, but I guess as I understand, the most effective drug in the world is aspirin, and after that, placebo. And so one thing that you are getting from your supplements is the placebo effect, even if you know it's a placebo. I mean, it's the most wonderful effect. So I mean, I think that there could be a genuine benefit through that route.
Just to add a comment, you're asking a really broad question. When you say supplements, you're talking about 40 or 50 different compounds, and there are extravagant claims made about a lot of them, and some of them are really vital for normal physiologic processes, and it has been shown that taking them will prevent, for example, neural tube defects in the case of folate. And this was established by a clinical trial. There's really a tool to answer these questions, and I would say you should be a skeptic like I am and like all of us are, and probably unless there are really strong clinical trial data, you shouldn't believe it simply because someone says they feel better or this or that.
A show of hands on the panel. Who takes vitamin supplements?
The guys.
We're always much more
Vitamin
D.
Vitamin D.
Do we have another question? There's a lady here about a third of the way up.
Hi, I'm Mena from Australia. So my question is, I'm wondering what's the views of patenting genes, and how do you think that will impact the future science research?
Marie-Claire, the patenting of genes. You bear a few scars from this.
You're right. My views on this have evolved a lot as I've seen women die of breast cancer who had inherited mutations in BRCA1 or BRCA2, didn't know it because they didn't get tested and didn't have the money to get tested. When BRCA1 and BRCA2 were first cloned in the mid-1990s, I honestly had no strong feelings about it one way or the other. There had not been a history prior to that time of patenting genes. Arnie Levine never patented P53. I mean, it just wasn't something that was done. But there had been, in the early 1990s, a trend that Jim Watson, when he was head of genome, fought very hard against, which was the effort to patent entire swaths of the genome on the basis of little tags. And the NIH, pushed by Jim, resisted that, successfully resisted that. But the NIH did not resist the patenting of complete genes. And at the time I thought, well, the most important thing was to keep the genome in the public domain. I now think that it would have been, in retrospect, it would have been far better for the public health had the NIH taken the more complete position of resisting patenting genes at all. My view is that genes are a product of nature, that a gene should be no more patentable than my left thumb, that the drugs that are developed from knowing genetic information should certainly be subject to patent. I don't oppose patents in principle. But that a patent on a product of nature, in fact, demonstrably in this case, has precluded the application of better technologies to make genetic diagnosis, to make genetic screening cheaper and more widely available. I think we have in BRCA1 and BRCA2 an unfortunate example of what the consequences of gene patents have been. Right now in the US, this case is going back to the Supreme Court, and I hope that by next summer it will be resolved.
Jim, do you want to add anything on that?
Yeah, I completely agree with Marie-Claire.
I mean, just...
Yeah, of course. No, we're always friends.
Just to throw a small hand grenade into the conversation and take it further in a way. I've become something of a patent anarchist in all of technology, with the possible exception of pharmaceutical drugs, where you have to do something about rewarding the people who go through long, expensive clinical trials. But certainly in software and in other, the evidence that patents encourage innovation is rather poor, and the evidence that they hinder them by allowing people to erect phantom toll booths across the path that you need to take for innovation is, I think, growing stronger all the time. The analogy with private property in terms of real property is actually a very poor one, I think. So,
also, if I may just add to this, there's also some recent work done by economists, of all people, who look precisely into in which ways do patents hinder innovation at the very early stage? Because others do not move into this field anymore. They say now, you know, there's a patent on it, so there's nothing in it. So on a much broader front, you hinder innovation.
Well, there are patent trolls, which are firms that buy out patents with no intention of developing the technology, but every intention of milking the patent infringements for money. Anyway, I've probably gone too far, and there's nothing to do with the subject. Have we got another hand up? Yes, in red, just there.
Hi, my name is Joel. I'm an environmental study. I study environmental science. But since we have a philosopher here in the panel, I would like to ask, for the most part of our human history, our societies have been very deterministic. If your father or your family was farmers, you were going to be a farmer. Would it be so bad now if we went towards a more deterministic society? Is this idea of determinism really that bad?
That's a lovely question. Right, who wants to tackle that first? Helga, I think.
It was addressed to John, and I can't.
Okay, John.
I mean, that's a very big question. The first of all, of course, when you, as always, with determinism, one's got to be more specific. And I think what you specifically mean is determinism of social role, social status, position, so on. Well, that's a very large question. I suppose that in some ways it's no doubt the right kind of stable society. People would be happier. I mean, the thing that makes people unhappy mostly is inequality. We have worked out a system that we live in now which promotes inequality in a very serious way. So there may well be that we could be a lot happier in a society in which people were born into their place and knew it. I can't find myself kind of morally or politically excited by this, or partly because I suppose that what I think is one of the things that's good about our very unsettled, unstable societies is they seem to be very creative. And I guess it's hard to be creative when everything is fixed. And we wouldn't be, I think, sitting here talking about, you know, some cutting-edge science if we were living in a sort of feudal society in which people, you know, knew their place. We might be happier, or most of us, except unequal people like us who are on the right end of the...
In my talk this morning, I mentioned the beginning of modern institutionalized science. And it started, if you want, with, although some of these early natural philosophers, they were deeply religious personally, but nevertheless it started as a revolt against the authorities, both of political and religious authorities. And so questioning the order of society as it appeared to be God-given or natural. And I think without that, you would not have had this explosion, this cultural evolution that, you know, that we have seen. Now, of course, in terms of happiness, yes or no. I mean, you know, some people may have been happier if you know, but I see no way of going back to this at all. and there is just in a way, but it's a different kind of inheritance. You mentioned money, being inherited. So, money has in some way, it's being inherited. Money has become a very deterministic influence. And this is...
Wasn't it always, though? I mean, I'm baffled by this idea that we're a uniquely unequal society at the moment. If you go back 100 years, not only was income inequality far greater, but health inequality was greater. People were 3 inches taller if they were in upper class than in the lower class 100 years ago.
Absolutely. But the inequality that we are witnessing now dates back to the 1970s.
In the West. But global inequality is still declining.
I agree.
Global inequality is still declining because people in poor countries are getting rich faster than people in rich countries are getting rich, particularly in the last 5 years. So if you can measure this...
Could I just correct? I think the assumption, which may be false, is that inequality makes people unhappy in a society that preaches desert as the explanation of inequality. But I also just want to say, and of course I was wrong, it's not the most unhappy making thing. The most unhappy making thing is not having enough to eat. So this is all on the assumption, I think, on these studies, that you've got your basic, that you've got basic, minimal, decent standard of living, which is pretty low. But
so your call to recreate the feudal society is generally rejected by the panel.
May I ask a question about that follows up on this? You were discussing the Renism, absolutely deterministic, fixed societies. We had some of the most beautiful flourishing of art. That is, the popes, among obviously it's a social system that we would reject, but they supported art, they supported painting.
They imported the artists from free city-states like Florence. They didn't grow them. Wrong way around.
Okay, very good. Well done.
We've got 5 minutes left. So should we take... maybe the time has come to just go around the panel for one last final comment, unless anyone's got one burning final question. No, go on. Jim, would you like to start by just giving us your final thoughts on this subject? We've ranged over a huge width. I hope people don't mind, but I think that was quite interesting. We've picked up some stuff along the way.
Well, I think there are a lot of moral consequences of genetics, and worrying about genetic determination is a sort of irrelevancy to the problems that really come out of just differences in people and how we treat them and what is a good society. So I find the philosophers should really accept genes and just get on with the implication, knowing they're not everything, and we don't want to say it's 80% genetic determinism or 60%. There's problems in either case. That we have inequality, and how you deal with inequality in a society which we can live comfortably in.
John.
Well, I certainly agree that genes aren't everything. There are probably more important questions, but they're pretty interesting. And I suppose the moral from some of the things that we discussed that I'd offer is we should be very careful not to generalize almost anywhere in this. Now, I may be, I think I'm tempted to generalize a little when I get excited about epigenetics as a middle-class English person. But for example, when Jim was talking about the genetic diseases, the genetic mental illness, surely there's genetic mental illness. Surely there's also non-genetic mental illness, as, for example, in the epidemics that some of you may know Ian Hacking has written about, where suddenly, from something that's only recorded twice, there are thousands of illnesses. We know this with disease. There are certainly genetic diseases. There are certainly diseases that are not mainly genetic. And so I think, the thing is to try and to get a very nuanced view of how diverse this is, how diversely genes and environment interact in different cases, and just avoid any, sweeping isms that tell us what is happening in a general way.
You would not be surprised to hear that I follow the same line, but I would put it slightly differently. I think the challenge before us is really how we deal with differences. And differences can be enriching. When we speak about diversity, we want to get different perspectives. And differences can be used as a mechanism for marginalizing people, for looking down on people, for excluding people. And then it matters which differences are you using to do that. And genetic differences have to be seen in a broader range of differences that we make. I mean, the parents, the wealth of your parents, the kind of upbringing, the schools your parents were able to send you to, etc., etc. Now, this is not genetic. Nevertheless, it is part of the environment in which some people are born and others are just the reverse. And this brings in the question of fairness and how does a society deal in establishing norms of fairness. Right. Now, with genetics, as I said, it's irreversible. You cannot go back, at least until now, and change it. While in some other cases, you can have mechanisms in a society that at least try to repair, to compensate, etc. So I think this is my view of the issues we are discussing.
I've learned a lot in this discussion. It's been a very good discussion. I think that what we are resisting is determinism of any sort. And what we as modern people would like to believe is that it's not necessary to accept determinism. And I certainly want to believe that. And it's not my geneticist hat that makes me feel that way. It's my hat as a mother and as a citizen and so on, and as a feminist. And I think that the way to focus then is to think, what are the strongest influences on the success of a child? And I think they're what you just said. They're the quality of the school that the child attends and the quality of the attention from the parents. And that genetics plays a very small role in that. That focusing our energies on the quality of schools and the capacity of parents to have enough time and education themselves to be able to dote on their children, to be able to devote that energy to the children, is the best way of battling this question of determinism.
Bruce.
Well, I have to admit, since I never went on record before, I certainly believe that there's a deterministic element about genetics. No question about it. I'm all with Jim on that. But I'm also a humanist. And I agree with Helga, and I agree with Jim, I agree with all of us, I think, that this shouldn't be a guide to how we treat people. We should have the morality to accept the situation as it is, whether it's for better or for worse, to try to improve it as best we can, realizing that environmental tools are the only ones available to us. And I think everybody would agree with that.
If I can have the very last word. 15 years ago, when I was writing the book Genome and the Genome Project was coming to completion, I was very struck by how many pessimisms were out there about what this technology would lead to. Murderers would be let off because they would say it was in their genes. Insurance companies would refuse to insure us. Rich people... what would rich people do? I can't remember. Anyway, they were going to do something. They were going to get special genes for their kids so they could learn music better. None of these things are happening. On the whole, all sorts of diseases are being helped, etc. So the good stuff is outnumbering the bad, and we shouldn't alarm ourselves too much with hobgoblins. Will you join me in thanking this extraordinary panel? And I don't think we'll ever see such a concentration of talent on a stage.